The concept for EPARTRADE is basically, in my opinion, there's a big hole in the internet. So the internet started many years ago, but there's never been an online business community for racers on the World Wide Web. The need for EPARTRADE is actually quite obvious. Basically, people in the business of auto racing need a place online to hang out and to get their problems solved.
It's extremely simple for a buyer or for a supplier to interact on the platform. The first thing you need to do is sign in, which is free. And the second thing is, when you see a product that you're interested in, all you need to do is click on request more information. If it's a company, you click on request more information, and then from there, it is forwarded directly to the buyer or to the supplier.
You can go to EPARTRADE.com, you become part of a community of businesses in racing, and it makes sourcing products much easier than just on the internet or using Google.
At EPARTRADE, there is no e-commerce. It's literally a connection just like at a trade show. So now, any time of the year, a buyer could reach out to a supplier through an email.
More than that, it's a place to go just to keep current every day. So it's a good place to start your workday in your racing business or in your offices of your professional race team. And you know you're current when it comes to new technology, industry news, technical papers, technical videos, all of that and more. We're not looking for a million hits per day. All we want is people who are really the volume buyers of racing products in the racing industry to be part of the little world of EPARTRADE. We have racing businesses participating from around the world. So you get suppliers from around the world, you get buyers from around the world.
EPARTRADE really eliminates having to travel, closing down your shop. Now you have a place to showcase globally your racing product and technology.
Good morning from California. I am Francisco Savignan, the founder and CEO of EPARTRADE. With me this morning is Judy Kin, the co-founder of EPARTRADE, and the wonderful Jeff Hammond, our great host, who was in the winner circle a few weeks ago, right? Oh, recently, a couple of weekends ago, Jeff, right?
Yes, I was very blessed, working with the SRX guys. I had Tony Stewart as my driver, one of my drivers that night, and up at Eldora, and we were able to hold on and win an round as far as the 6-race series we got going on. And this week we're going to be headed back up to Wisconsin to the Slinger area, Slinger Raceway, and we'll be putting on another big show. So we're really excited about that.
Excellent. Congratulations, Jeff. That's
Thank
a big deal. Judy, you have some big announcement to make, right?
Yes, happy to announce that we finally have a sponsor, presenting sponsor, ARP Fasteners. They jumped on board this special sponsorship. See their logo right there. And it's just, we're so lucky to have worked at PRI for 20 years, and we have great relationships with both buyers and suppliers.
Yeah. You work with ARP for a very long time, Judy, for sure. That's we're delighted to have them on board with us. So thank you very much. And I'm getting a signal from our producer, Reed Keneski. We're going to bring Mark Hervé, who is a dear friend of mine. So Jeff, we're going to be talking French today, right?
If you say so, you may have to stay on with me.
So Mark is based in France, and he runs the entire motorsport division for Oerlikon around the world. So I see Mark popping up. Good morning, Mark. How are you?
Hi, good morning. Good afternoon, everyone. I'm good. Thank you very much.
Okay. So Jeff, you're in charge, and we'll see you in about an hour.
Okay. That sounds good. But don't you go very far. I may need help.
I will be right there. I will be right there.
Yeah, don't leave me hanging there. Good morning, Mark. How are you doing, sir?
I'm good. I'm good. Thank you very much. I mean, it's a great opportunity for me, showing what the company Oerlikon can provide in motorsports through EPARTRADE. And please just be nice with me, okay?
Okay. What time is it where you are?
6 p.m. actually.
6 p.m. Okay.
Yeah,
well, you kind of like ending your day, then we're just kind of like halfway through ours.
Yeah, so we're good.
Yeah, we're good. I've had the pleasure of having somebody come on from Australia, and I caught them at like I think about 3:30 in the morning. So that's the reason I want to make sure what the time clock was. But Mark, go ahead and kind of I've been doing some research on y'all's company, and I mean, it's so massive. I mean, it covers so many different things, not just racing, but you know, the aerospace industry, as well as the medical industry. You guys, I mean, I mean, to me, I'd have to say you're like a gigantic octopus to a certain degree. You got arms everywhere. So, how about bringing us up to speed and lead us in the right direction? Because here again, this here is an area that I have some knowledge of, but I would be better served to say I have no knowledge of. So educate me.
All right, good. Thank you very much, Jeff. So I'm gonna share, a presentation. Basically, the idea is to go through some somehow theoretical things, but please interrupt me anytime. So this way, we give actually more interaction. Let me know when you see the screen.
I see the screen, the powerhouse of innovation in motorsports.
All right. All right. So thank you very much.
Yes, sir.
So as I say, just a few words about me, because you guys now are very well known from the whole motorsports industry. But for me, as you may recognize by my accent, I'm actually French. I've been working in the coating industry for now 22 years. Maybe it's time to do something else. I don't know. And I've been lucky to work in the motorsports industry for at least 20 years. So I still remember the very first time that I met Francisque, which was yesterday. And I'm still enjoying every day since then, talking with very high skilled people into the motorsports industry and actually worldwide. So what I would like to go through is very few words about Oerlikon, the company itself, give you a quick introduction to the technologies that we use for the motorsports industry, a couple of application, how we can combine everything. And which is why, we said that we consider ourselves as the powerhouse because we can combine solution, a few words, and depending on the time we get, go through an open discussion. But all along the presentation, Jeff, if you have any questions, just interrupt me. Okay.
We'll do that, and we'll keep an eye out, for the folks that are tuned in. I think we got some folks already that are very eager to learn about what's going on here. So as we go along, if they throw a question out there, we may call a timeout and try to address it at that moment. Okay.
Sure. Thank you very much. So few words again. I'm not going to bother you with tons number, but as you say, Oerlikon is a massive group, which is composed today of two big divisions. One is what we call this polymer processing solution, which is more about fibers, yarns, non-woven product that you will find on technical textile or carpets, this kind of things. We both manufacture the yarn, but also the machine and the full automatization of the machine. But today, we're going to look more about what we call the surface solution division. So in surface solution today, we have different kind of subdivision and different products we can offer. Very first one is what we call Oerlikon AM for additive manufacturing. So it's going to be the 3D printing branch. Oerlikon Metco, which is, as you can see on the picture, it's more a coating division about thermospray, thick film, I will show you more afterwards, and Oerlikon Balzers, which is more about the vacuum coating and the thin film application. So as you said, today, Oerlikon, Balzers, Metco, and AM, we are covering a lot of different industry. It goes from aerospace, medical, the semiconductor industry, oil and gas, but here today, it's really all about motorsports. When we look to the three divisions, Balzers, Metco, and AM, we are talking from diffusion or micrometers up to real parts. So, with the colleague from AM, we're going to talk about real parts, printed, physical part that you can have in hand. With the Metco technology, we start talking in a few hundreds micrometer up to millimeters, really. So I will refer very often to Metco as, the thick film application. And for Balzers, we talk about thin film. simply because, as you can see here on the picture, it's only few micrometer coating that we're going to apply. So here, I'm not going to spend more time on the company itself, but I don't know, maybe you have already a few questions.
Well, I was just looking here and what you're starting out and what you're saying, make sure I'm following your lead, is that with the coatings you have, it could be, like I say, not even enough to know it's there type coating, and you can build from that point and make it thicker. Now, is this an application that we find with bearing companies maybe that send stuff to you to have bearings coated so that, you know, they could improve the wear as far as the bearing's concerned?
Yeah, exactly. I mean, bearing is one of the applications that we have. Not much really in the motorsports application today. Bearing today, we work more with, for example, you know, wind turbine application, this kind of a big roller bearing,
Right.
where we got a lot of loads, a lot of wear, and where basically, you know, you cannot change anything on the wind turbine every Sunday because there is something wrong. But here you will see a few application later in the presentation. But yes,
Okay.
it goes from different thickness, different application. But on the coating part, we will always focus about friction and wear. That will be the main focus of what we're looking at.
Okay.
So maybe I can go through the technology, and I'm pretty sure that that will be here that most of the question, you know, will come. Once again, keep in mind, I am I would say more thin film specialist. So I'm just, you know, taking the lead for my colleague from AEM and Metco. So don't be surprised if I say something maybe wrong or not as accurate as I should be. But, you know, as any product, any technology, there is not only one solution. So if we look to additive manufacturing, 3D printing, there is a lot of different technology today out there on the market. Most of the time, we found what we call this metal powder bed fusion, where basically you will have a slot with the powder, which is basically the material we're going to use to print the parts. And layer by layer, with a laser or multiple laser, we're going to actually melt the powder and build the part itself. Similar technology is also what we call the, you know, the SLS technology, so selective laser sintering. So both are working in the same principle, that layer per layer, we will build up the parts. Mm-hmm. Other technology, or I would say even closer to the coating part, you will see later, where basically you will have the powder, and thanks to a laser beam, again, we're going to melt the powder, the product, and then again, we will build up the part. And recently we worked also with technology that we call clip, which is basically mainly for the polymer application, when we combine, you know, the UV light with the resin in order to build up also the parts. So one of the strengths about Oerlikon is that we work for the complete supply chain, from creating the powder, the material itself, down to making, you know, the design of the parts in collaboration with the customer, print the parts, do all the, I would say, the post-processing work, so including the machining, the heat treatment, the surface finish, and then do the full final control, both visual on the coupon and on the parts with the quality standard. So here, you know, we're not just I would say a basic printing company. We can really cover the whole supply chain for this kind of application. Just to give you some example also of the kind of material and size of machine that we use. So here, these are the material that we print the most commonly. So, you know, it goes from nickel, titanium, aluminum, metal, copper base. And we have a lot of different material, let's say, qualified today where we got experience. But as you can imagine, we have a lot more, let's say, exotic parts or material based on very specific customer requests. But it can go from very small parts, very small machine, up to part that goes from 500 to almost 450 millimeter range. So we can go from very small parts to pretty big parts up to, for example, a monocylinder engine blocks. This is the kind of thing that we are already printing in the past. So again, it's just to give you a quick shot of the technology. But here, AM again, complete supply chain, different material, and definitely different size of the machine depending on the needs. If we move then from the parts manufacturing to the coating, really the coating. I'm going to talk now about the thin film, so more what we call the Balzers application. So again, think about it when we talk about coating. Most of the case with a thin film application, we are looking to prevent the wear and reduce the friction. So it means that 95% of our application are really tribological application. So this is why before talking about tribology, just a quick reminder, what is a tribo system? So a tribo system will be composed of two different parts that could be made of two different material and working into a certain environment. So this environment could be oil, it could be part of the engine, or it could be on a completely dry situation. But sometimes, you can have particles coming from the outside. The engine won't work the same way if you're racing into the Dakar in the middle of the desert, or if you're on a clean track on the weekend. So all these parameters will be, let's say, the working environment. And when you will start applying pressure and motion on one of the two parts into this environment, you will create what we call the third body. And this is where the whole magic happens, that the third body will be then where you will create the wear, the friction, the behavior of the component. So here it's very basic reminder, what is a tribo system? The reason why I'm showing this is because when we talk about thin film, so again, keep in mind, we are talking about few micrometer thick. Surface roughness, surface finish actually matters because the coating is going to reproduce exactly the surface finish that we have before the coating. So if you get something shiny, highly polished, we do the coating, it's going to be the same afterwards. But if you get something which is very rough, the coating will just reproduce exactly the surface. So the risk is that at the end, you have your coated parts with the high roughness, and the coating will keep all the, the high peak of the finishing. So if we come back to that into our tribo system, so again, two components, you start applying pressure and you start putting a little bit of movement. So many things wrong can actually happen when you get your coated parts. One of the possibilities is that the coatings being so hard on the rough surface, you start to be abrasive for the counterpart. So in one hand, everybody is happy, the coated parts get no more wear, but for the whole system, you still have wear. So no good. Other possibility that the counterpart is hard enough, leading to the fact that we're going to start breaking the peaks of the roughness, and suddenly you will have micro coated particle into your, your third body, and suddenly you will have wear because it's going to be very abrasive. Or third possibility that the counterpart is actually so soft that you will make a transfer of this soft material to the coated parts. And suddenly you're back to uncoated surface. So you don't have any benefits from the coating. So again, here is just a quick reminder that the coating is one thing, but the way you prepare the component before the coating makes a big difference at the end for the use inside the engine, for example, if we talk about motorsports application.
Okay.
So about the coating itself. Today, a lot of people are talking about, they are saying, oh yeah, I'm using a coating, I'm using a PVD coating. I don't know, Jeff, if you ever heard about this kind of term, but many people are mentioning PVD coating, which is at a certain extent completely wrong, because a PVD coating doesn't exist. PVD is in fact the technology that we're going to use to apply the coating. And PVD stands for physical vapor deposition. So basically the principle is that we will take the parts, put them inside a vacuum chamber, and then we have different processes how to make the coating. So one of them is what we call the sputtering. So on the side of the chamber, we will have big targets which are going to be made of the material we want to apply on the parts. So it could be a chromium target, it could be a titanium target, it could be almost whatever material we want to apply. So the parts will be put onto planetary system to have a good uniformity of the coating all over the parts. And then we will create, a plasma environment, and from the target to the parts, with the plasma and the way the polarization of the parts, we will have a movement of ion from the target to the parts. And this is how we're going to do the coating at a certain extent. Here, with the sputtering technology, coating will be made below 250 degrees C. So we can almost coat every kind of material. Another technology which is very close is what we call the Pvd Arc, where here in this case, we will again have solid targets of the material we want to apply, and we're going to create an electrical arc on the surface. And by doing this, we will have a very dense, very hard coating, but this process is made at much higher temperature, up to 500 degrees C. So we got to be careful about the material of the parts. Another coating or technology which is very well used is what we call the DLC. DLC stands for diamond-like carbon. So it's basically an amorphous structure between the graphite and the diamond. And this is why the DLC is very interesting, because it gives a very low friction that you can get from the graphite, but then the very high hardness from the diamond. But DLC is a big family of coatings. So everything you can find here into this triangle, for example, on the chemical level, can be called a DLC. So DLC is not one thing. Is somebody say I'm using a DLC coating? Yes, I'm driving a car, but you have no idea about the performance, the characteristic of the coating. Here, the coating will be made again under vacuum, but into a complete plasma environment. And it will be then done at a much lower temperature. So for sure, below 250 degrees C, we can even go down to 150 degrees to coat aluminum parts, for example. DLC here, I mean, I'm pushing it really hard because DLC is probably the most used coating when we talk about valve train parts. But I really push that because DLC is not one unique coating. It's a really wide family of coating. And depending what characteristic you're looking, we can adapt the coating. And today, Oerlikon Balzers has all the technology to cover all different family of DLC you can find. But here I showed you different coating, different technology. Unfortunately, today there is not one coating for all. It doesn't exist. So depending the application, the parts, the environment, we may have to go through different solution, meaning also different technology. So if you look mainly for friction and wear, it could be a carbon base like a DLC. If you look to temperature protection, For example, on an exhaust valve, we might go to a different kind of coating that resists to much higher temperature. And if we want to go even higher, then we might have to move to oxide coating that can resist to more than 1000 degrees C temperature. So the coating industry is quite complex, and depending on the part, depending on the application, we will have to pick different technology. Do you get any question, or I completely lost you already?
No. I'm trying to follow, because the idea of charging some things, with a almost like a magnetic type of a charge to make it, stick, and then understanding the different temperatures of your coatings. I guess the one thing that I'm curious about is when you go through the different applications, in which, you've very nicely summed it up here on this final chart, that, exhaust stuff, which in maybe brake type stuff, that need to be coated, would be in that 1200 degree, that range. But other stuff we want to wear, it's not really, it doesn't need to be superheated. So, you have that range, and you can kind of like pinpoint it. But the other question I got is that on your coatings, for your coatings to be the most effective, do you have to have, matching surfaces? Does that make sense?
So I see what you mean. I will say that today we got many applications where we're going to coat, both parts. But
Okay.
if I take, for example, in Formula One, when we go with the finger, the rocker arm configuration, due to the level of load, very often we're going to coat the finger follower, rocker arm, and the camshaft, for example.
Okay. Mm-hmm.
But in most of the case, coating only one of the two surfaces will give you something like 80% of the total reduction you can get compared to if you coat both parts. So, this is why, depending on the application, it sounds crazy, but depending on the budget, of course, sometimes coating one part, it's going to be enough. You just got to be careful that the counterpart is also not a big, bag of sand. You need to have also a highly polished surface against the coating, or obviously it's never going to work. But it's not an obligation to get both parts coated. One part coated gives you already a major benefit compared to no coating at all.
With the coatings you have just recently showed us, is your diamond coating the hardest, in your family, or is there something that's even more durable than that?
No, I mean, today when we look to, again, tribological application, where we look friction and wear, DLC remain the highest one. I mean, we are talking here up to 35, 40 gigapascal hard. So it's probably 4 to 10 times the material hardness, depending on the substrate. So here the DLC family is going to be really the highest hardness that we can get at the moment.
Okay. I know we touched on that, but I'm gonna make sure we focus directly on this. Rich Torme, which is one of our attendees, is there any limitation about the material that can be coated?
I have to say, I got to be careful on my answer, because if I say no, yes, we do have limitation for the coating itself. As long as the material is compatible with the coating temperature, we will have no issue. The only thing that we have to keep in mind that 3 or 4 micrometer thick coating will not replace the hardness of the core part. You see what I mean? So if you get deformation, it's not 3 micrometer that's going to change this deformation. So you need to have a very hard substrate first that can support the load, and then the coating will just improve the wear and the friction, but not the deformation itself.
Okay, we got another
So this
follow-up
is,
question here from John Damasowicz, and he's wondering, are there any machinability issues with any coatings?
again, 3 micrometer here in this case. So, sometimes we coat parts which are not fully machined, fully finished. But for some reason, it's easier to coat the parts at a certain stage. So we apply the coating all over, and then some very specific area are machined afterwards. And therefore, again, it's only 3 micrometer. So as soon as you get inside the material under the coating, machining will be almost as usual. And the coating won't, break. It's not because you're going to machine that where you're going to have the machining line, the coating will start to, come off or whatever.
Right.
It will be a clean machine, clean line.
Okay, very good.
So let me move then to other technology, which is more about the thick film coating. I know that there were already previous presentation about this technology already in EPARTRADE, with the Sumibor coating, which is Sumibor is really a technology that we use specifically for cylinder board. And here we are again on a complete different technology. So basically, we're going to use a torch, where basically with the torch, we're going to melt the powder and create, this kind of spray. So basically, all the particle, the powder, will be melted, and somehow with the energy will be, splashed onto the surface. So to use a reference from a colleague, all this kind of pancake design will be in fact the different particle of the powder melted, but with the energy will be stuck and piled one on top of the other. And depending on the powder, depending on the composition, we can mix different things with melted things, oxide particle, in order to give multiple properties to the surface. So if we look specifically to the cylinder bore, the process will be that, we will get the blocks or the specific liner, which will be slightly oversized. We will have to, let's say, activate the surface before, and at the opposite of the thin film, where you need to be perfectly polished, actually here for the thick film, it's better to have a certain kind of roughness in order that, the particle get really embedded and melted onto the surface. So you prepare the surface, you pick the right material, powder, depending on the property you're looking. Then with a rotating torch, we're going to apply the coating on the whole liner. And finally, as you saw, with all these pancakes, the surface will be completely uneven. So by doing a final machining owning, then first you get the right dimension, and also you get the right finish needed for the application.
Okay, well, let's slow down right there for just a second, because this might apply
Sure.
to the question that came up. Your chart a moment ago, there was a large range of hardness, of the carbon-based coating. This is coming from James. Yep. It would seem that there would be some benefit if choosing a somewhat softer carbon coating so it would wear into its acting surface. Yes or no, and then why? And obviously they said thank you. But I think you're kind of addressing some of this right here in front of this. Am I wrong?
So, again, the carbon coating application and here the Sumibor are slightly, you're not looking for the same properties, but I will actually answer these questions in a few slides with an application, and you will understand actually I agree with him that sometimes having less hardness is actually better. But again, is application dependent, and you will see it in a few slides.
Fantastic.
So here, just to say, in the same spirit as for AM, what we do on the supply chain, with Metco, basically, so here you can see what I was talking about in terms of activation, your preparation of the surface, either we do via machining, so you will really make this kind of geometry, or use a laser. And this way you increase the actual adhesion of the coating and the spray. Our work is, literally the thermospray, and basically both on the activation or the owning, we work with a lot of very good partner around the globe, depending if you're based in the US or in Europe or in Asia, for example, in Japan, we are working with very well-known, with high reputation companies about honing, for example, because we know it's a key part of the process. So here, really our work, but we can take over the whole supply chain here from activation to honing, working with partners. All right, enough about the technology. Let me show you then now some applications. So additive, it was very difficult for me to show a clear application, because the benefit of additives is that there is almost no limitation, almost. The big interest of additive is that actually you can go with very complex geometry. You can do things that you will never achieve with standard machining, with conventional machining. The interest of additive that you can combine different elements that with standard machining, you will have maybe 3, 4, 10 parts to compose, one system, while with the printing, you can print everything at once. You can play on the geometry. You can go with very thin wall, where again, it will be too risky to do with traditional machining. And with the range of material we can cover, you can really play in terms of thermal properties, making cooling channel on complex parts, for example. You can parts based on copper, aluminium. There is definitely a lot of possibility and opportunity with AM. When we talk about additive and motorsports, the interest is the speed. Printing, machining a part takes weeks, literally weeks. And we know in motorsports, every day's hours are key. So by going with the printing, you can be much faster than doing conventional machining. You can also then combine, as I said, a different geometry, be faster, complex parts. And this is really where the whole interest of additives is today. If we look to the thin film, as I've shown before, most of the application we got are tribological application. So here on the screen, it's literally most of the parts you can find today inside an engine on the drivetrain. And here, DLC coating is the most used coating. So, it could be the flat tappets, a roller lifter, finger follower, then the camshaft. Here, this is where you will have the biggest loads, wear and friction. And by putting the coating on these parts, you will dramatically reduce this effect. Piston pin is probably now the most common application with a DLC coating. Here, applying DLC on the pin will give both extra readability because you get less wear, but it will also help you to get rid of the bronze bushing, for example, on the connecting rod. So first, you get rid of the weak parts, and it allows you to change slightly the design of your connecting rod to save a few grams, maybe give a different design. When we were talking about the valve, depending if we talk about inlet valve or exhaust valve, we are not looking for the same properties. On the stem, whatever the case, DLC will be the best coating because we are looking to the lowest friction possible against the guides, the copper beryllium guide in most of the case. But when we look to the coating on the head, the temperature on the inlet and the exhaust won't be the same. So for the exhaust side, we will look to coating that can resist to really high temperature, up to 1,000 degrees C in case of a turbo engine or these kind of things. Inlet, again, is going to depend on the engine, but we can do different coating on the same valve, depending on the needs and depending on the kind of engine. If we look then to the gear train, and this is where I'm going to answer the previous question about the hardness. When we do coating on gears, gearbox and the gears, it's a mix between shocks, rolling, sliding. There's a lot of different things happening on the gearbox. And here in this case, actually, harder is not better. Because if you go with a too hard coating, it becomes brittle and basically can create cracks and get delamination. So here in this case, we will remain with the carbon-based coating because we look to reduce the friction, but with a softer one. So this way, we create some kind of a running in step that also do a little bit of transfer from one part to another one. And for the gearbox, the interest will be, to have the coating and push back, the pitting and the wear that you can see on some gears, for example, on the teeth. But then, we can coat also the shift trays, the selective fork, the dog rings. There is a lot of parts in movement inside a gearbox. And again, it's really case by case. And yes, harder is not always better. Here, a very common application that a lot of people see now on the market is the coating on the suspension tube, for example. Very often you see this gold color on the tube, which is in this case what we call a titanium nitride. I think it could look nice on the bike, but I'm more about technical property than really, the look. So this is why I prefer to apply a DLC coating on the tube because we combine again the hardness for the friction, for the wear resistance, and then a very low friction. We did some tests with a couple of customers, and we measure up to 20% reduction in terms of the friction. And this translates to a benefit for the driver because the suspension will be a little bit smoother and you get a better feeling, with the track. So here is a good example where friction is really making a difference.
Okay, let me interject this right quick then. The coating and making the difference right there.
Yep.
The 20% reduction in friction, and that correlates back basically to heat, correct?
No, it's literally about the interaction between the sealing and actually the coating. So the 20% is not about the heat. It's really let's say the power you need to make things move. Due to the composition of the coating, you have less of the, let's say, the sticking effect that you can get with the seal, for example. And this is why basically you have this reduction. So it's not related to the heat, is more here in this case related to the composition of the coating and how it's reacting against the sealing.
Okay, because and the reason why I was saying that, I was thinking if you're reducing the friction, most time when you reduce friction, you reduce heat between the two parties.
Agree.
Okay.
But here on the suspension, we're not talking really about heat, but I agree that on the valve train, sometime it will have an impact. I completely agree with that. Yeah.
Okay. Thank you.
You're welcome. For the thick film application, so we talked about the sumibor coating before on the liner, but there is a lot more application depending what you're looking for. We can look for more thermal barrier, process and application, for example, on the head or on the piston crown. there is a lot of possibility. So the sumibore is really on the inside of the liner. And for very severe application, we can do the coating also on the inside of the connecting rod to be less abrasive. And there is a lot of things on the engine where we can apply the coating. But again, between the thick film and the thin film, I will say that these coating are not really in competition. They are more complementary simply because they have different properties today.
Okay, Mark, we have another comment here, and
Sure.
you know, you were talking about all the different varying parts and pieces and like that. But from your comments about surface finish, would you recommend an REM finishing prior to the DLC coating on gears?
All right, let me come back to gears. So, you know, we know from the industry that the REM finish is giving a great benefits because once again, you know, by applying the REM finish, you get rid of all the positive peaks of the roughness, and therefore you get a better contact, and therefore you get a better performances. But you don't change by doing it the way that you may have wear and the pitting effect. You can postpone it, but after a certain time, you will still have the wear and the pitting. So having a REM finish plus a coating on top is definitely a possibility. And the coating will actually act like it's gonna, you know, freeze the status of the part. It will keep the nice finish and the very smooth finish you get from the REM finishing. But we saw also in many applications, in our case, that by doing a microblasting prior our coating, which is in this case what we call the balinite C, we have also a very good adhesion and a very good behavior. And once again, we have that because the balinite C is not that hard compared to a DLC coating. So yes, we can do the coating on top of a REM finish part, but for the gears, it's not the only solution once again.
I hope that helps James out right there. Thank you for the explanation.
You're welcome. All right. One thing that I should mention is that today many of the applications that we coat have been upscale for many applications. This is why we call about from track to road. There is a lot of coating that we applied for racing application, which are now used on road vehicle. It could be motorbikes, it could be sports cars, supercar, these kind of things. But today there is a lot of things that we developed in the past, which are now also used on the road. I mean, when you look to some supercar today on the market, we got 1,000 horsepower and etc. The level of load is really incredible. So you need to look for similar solution and performance that what you get on the racing side. So this is why today for Oerlikon, we coat literally from application from one part, and we get other application when we coat almost 1 million parts per year because it's going to be a road car application. So it's just to say that the application are not only for high-end racer application with top-notch budget and etc. Coating today are really something that could be applied at any level as long as you want to push the limit. And one of the good things, being and working with Oerlikon is that with all the different technology that we have, again, if we come back to the pistons area, you can look about Oerlikon AM working and designing a pistons and printing the pistons. Then, with Balzers or the Metco, depending on what you're looking, we can apply the coating on the piston itself. Then we're going to coat, the piston ring with, again, different solution. And then it's going to work against a sumibore coated liner. Mm-hmm. So it's true that, today, by talking with Oerlikon, we are looking to combine solution. And right now, actually, we are working on a big project in finding the best combination between coating on the piston ring and a coating into the liner in order to get the lowest friction possible and the lowest wear. This is not possible with other company. If you want to do that with another coating company, you will have to talk to one company for the ring, one company for the liner. Here, you get only one company to talk with. So this is really one of the strengths of Oerlikon at the moment. If you have to, keep something in mind after this long presentation, and sorry if I've thrown a lot of details and information today, but Oerlikon today is definitely a global supplier, and for some application, as you saw, we are really working from designing and manufacturing the powder, the equipment, down to manufacturing the parts and putting the coating. And big strength is that with everything we get, both on manufacturing parts or the different coating technology that we have, we can cover almost any kind of solution. Keeping in mind that the only goal is always to increase the performances. And this is, the heart of motorsports, how to do more, better, faster all the time. Most of the time we consider ourselves as a design element, that when you think about a new application, start thinking immediately about the coating. We will support you. We will help you about maybe a little bit about the design, about the surface finish, what are the best conditions to apply the coating or how to design the parts. So we really want to act as a partner into the design of the parts and the application instead of just being an extra supplier on the list. And if I look to the team worldwide, as I said, based in the US, in Europe, or in Asia, we get people working for many, many years in the motorsports industry. So we get kind of good connections, very well, big knowledge about the application. So, we can help you, whatever the application, at least I think.
It sounds like that for sure. Question right now for me is, where is your base of operation? I mean, are you located in other countries, or is everything pretty much, in one spot?
No, I mean, today, if I look, for example, to Europe, this is where we got the most centers, for DLC and engine parts. Most of the things are done in France, but we have also a lot of application that we do in the UK, in Germany, in Italy, in Austria, just to name the biggest one in Europe. In the US, we got 2 facilities today. One which is, for example, in South Carolina, in Rock Hill, and then we got Elgin in Illinois, which are both doing the coating for the motorsports industry. But then we got plants, in Japan, and we got several plants also in Asia, South America. But for the motorsports industry, it's really the few countries I told you in Europe, 2 plants in the US, and then 1 factory in Japan, where we got the biggest knowledge.
Well, that's good to know. I can just run right down the road. Rock Hill is only about 35 miles from where I'm at right now. So and maybe I need to run down there and take a look at it firsthand, because it does intrigue me the way, Mark, the way your company is approaching all of this. And, we've had an opportunity to work and see with other companies that are part of EPARTRADE, as far as machining and deburring and everything like that. But it leads right into what you guys specialize in after a process, but also the fact that I can bring you an idea and you can work with me on the engineering side, and we can go basically from A to Z and get something done.
Exactly. I mean, and again, of course, if you're around, you will be very welcome. If you want to have a deeper look on how the coating is made,
Mhm.
You know, very often people think that coating is almost just a basic spray, but no, it goes through a lot of different steps from getting the parts, clean the parts, mount them, put into the chamber, you know, all the visual aspect, 100% of the parts are visually controlled. So it's not just a basic paint that we're going to put on the part.
Like I say, I find it, quite intriguing and interesting how this has evolved. And again, when I was reading the technology part of it about the broad base of your company, I started thinking, man, how could this really integrate into what we are doing in the motorsports field? But then you jump up and say, well, I've been doing it for 20 years. It's like, it's easy to see now where you've been working hand in hand with, and I'm sure that a lot of it comes because of being in the backyard of World Rally, as well as Formula One teams there, and the technology that drives that industries, both those industries, and how this would work. So, my compliments, sir.
Thank you very much. Well appreciated. But, very often people ask me, but Mark, how did you still survive in the motorsports industry? You know, because you got to be passionate.
Yeah.
And believe me, all the people that I know from this industry, they love their job, working with big teams, company, engine builder, part maker, having taxis, sleeping on the car park, waiting for the parts, and etc. This is our daily job. And you have to do that. If you want to be part of the motorsports industry, you have to work this way and this spirit. So yeah, we'll see. Been 20 years in. Not sure I'm gonna last 20 years again, but we will see.
Hey, real quick, John has got another question. He says, does the coating on the intake valve help in flow on the underside of the valve, or is it only for thermal?
Actually, if we go on a thin film coating on the on the fire face, the thin film coating will have no impact on the thermal properties because it's too thin. If you really want to go to a thermal impact, then we're going to have to go to a thick coating. But again, as I said, on the valve, it's really most complex parts because from the stem to the head to the fire face, you can have different coating, different technologies, case by case. But for thermal, that's going to be a thick coating. That will be the best answer.
Well, as I said earlier, we got about 2 minutes left here in our time. So if anything else you want to maybe share with us about anything that you guys have in the works as far as new products that are getting ready to be coming out and being available? I know that you guys are working 24/7 trying to come up with things, but
we do. We try to work on coating, which is always harder, smoother, because our customer are pushing us on a daily basis. It is, Mark, what do you get new? Do you get anything that would last longer? And we are very much driven by the regulation. When NASCAR or Formula One start to say that all the engine has to last longer, the quickest solution is basically to apply a coating. So this is where we also push to find always better solution. So yeah, we'll see, but more to come in the coming years, months, no doubt.
Really enjoyed this. I've really got my eyes opened up on some things that I didn't really know about. Really appreciate it. Also want to make a real quick thank you to the folks at ARP for joining EPARTRADE and being a strong supporter of this program that allows us to bring, folks like Mark on and have an opportunity to kind of quiz them, to get some insight where normally, it might be a little challenging. So thanks to everybody who joined us today. And again, thank you for taking time for us today.
Jeff, we have one last question. Do you want to run it for Mark quickly and then we can wrap it up?
One more question.
I see one
God.
more question in the chat.
Oh, I see it now. James, run one in real quick. Sorry about that, Mark. I'll have to hit you up for one more. Does the DLC coating, your diamond coating, have an increased affinity for lubricants versus the metal surfaces?
I mean, we could do a dedicated webinar only on this topic. So I would say that it is a complex question. It has an effect. It can completely change the property, but this is why, again, case by case. But yes, additive, lubricant, and DLC can change the way it works. But it's a huge topic.
Real quick, I saw one part during our webinar that there was for questions. You guys do have people who you can call up and get more in-depth information like this if you have more knowledge and want more knowledge.
Sure. Yeah, I will do so.
Okay.
So, but thank you very much, Mark, and we'll invite you back for another one. Yes, as you mentioned, we could do a second one, and thank you for sharing so much expertise. That was really great to have you on. Thank you, Jeff, as always. You did a brilliant job, and thank you, our great folks at ARP. So we'll be back next week at 9 o'clock for a double feature, Judy, correct?
Yes, we have SCAT coming on and also still racing products.
So yes, we'll have 2 hours, 2 sessions of 1 hour next Wednesday. In the meantime, we pushed Mark's product Oerlikon's on the homepage of EPARTRADE. So please take advantage of the platform. Thank you very much. The webinar has been recorded. It will be posted later on epartrade.com. Thank you very much. We'll see you guys next week. Bye.
Thank you very much. Have a good day.
Registering on EPARTRADE is easy. Fill out your name, email, phone number, and create a secure password. Next, select your business type. Choose supplier if you're looking to display products or services and connect with buyers. Choose racing business if you're looking to find new parts and connect with suppliers. Choose race team if you own or are a member of a professional racing team. Begin typing your company name. We most likely already have your company in our database, which you can select from the drop-down. Then, enter your job title. Choose Claim Company if you'll be editing your company profile. Other members of your company can choose Join Company if they'd like to use EPARTRADE as well. You can view and agree to our terms of use here. If you'd like to receive our weekly newsletter, choose Accept. Click Register Now, and your registration will be submitted for approval. You'll need to confirm your email once it goes through. To keep our platform industry only, you'll be approved shortly after. If we require additional proof of business, we'll reach out. Welcome to EPARTRADE.